Hi friends, hope you all are doing great. So today we are starting with a brand new module. We will be starting DP-900, right? That is the introductory course for Azure data related topics, right? It could be your Azure SQL databases or Cosmos DB or Azure Synapse or data warehouse services, right? So this is a introductory course, and in this course, let's go through all the content which we are going to cover. So we have a total of 4 modules, right? The very first module is all about fundamentals of data, right? Completely a theoretical module, and we will understand what exactly is the are the type of data which we generally store, right? In what forms do we store the data? What are the different type of databases available in the industry? And then coming on to Azure, what kind of data related services or applications are available in Azure? Apart from that, we will also talk about uh, roles and services. So, in your organizations, what kind of roles we have, and what kind of tasks are being performed uh, by those roles or the people who own those roles, right? So this will be the first module, and in this first video I will be covering the first module. um, After that, the second module we have will be the fundamentals of fundamentals of relational data. Again, guys, we will be focusing on the services which are there in Azure. So, of course, I will give you a brief introduction what exactly is a relational database, and within Azure, what are the services which are available for relational data. Next will be about non-relational database, non-relational data. And finally, the last module, the fourth module, will be about data analytics, right? This will cover the analytics part like data warehouses or Azure Synapse or HD Insights and all that, right? So let's start with the first module, which is the fundamentals of data and the roles and services. So, our first lesson will be entirely about the uh, data basics. Right now, guys, when we talk about data, what is data? Okay, I think we all have somewhere read this, right? Maybe in our schools, in our high schools or colleges or universities, right? We all have had a basic definition which we all read at at some point of time in our life, right? So what is data? So can I say that any useful information, or maybe it is not useful initially, but over the time through some means I can make that data useful in some form or the another, right? So it could be some sort of record, it could be some sort of maybe a file, a photograph, a video, anything can be data. Now, coming on to this IT industry, guys, we categorize this data into three categories. Right? We divide the data into three categories. The very first category we have is the structured data. The second type of category we have is semi-structured data, right? And finally, we have the unstructured data. Now, you know what? Let me start with the unstructured data, because that is the one which you might relate to very easily. So when I talk about unstructured data, it is something which there is no structure, or you can also call it as blob data. Sometimes you might call it as blob. So your files, like let's say an image file could be your .png, or it could be your .jpg or jpeg extension, but any such kind of file is a non-structured data or unstructured data. Or it could be a video file. Yes, definitely it could be a video file, maybe your mp4 videos, or any other extension could be a unstructured data. Or let's say a word file or a PowerPoint presentation file. These are your unstructured data. They do not have a structure. I mean, definitely in the backend, the data is stored in some form, right? But here, when I mean to say a structure, so okay, what is structured data? Maybe if I'll explain you what is structured data, it might be easy for you to understand that what exactly I mean when I say that it's unstructured or it is structured. So what is structured? Actually, this one might be very easy for you to understand. Guys, we all have seen a table in our life. Of course, right? We all know what is a table. We know that these are rows and these are columns. When I want to store any kind of data, like literally, you can create a table for anything in your day-to-day life also. For example, I'm going to create a family table. Let's say the information about the members of the family, right? So let's say the very first column will be for the serial number, right? And then we will what then let's say name of member name of member of the family, and maybe then we can keep their date of birth, right? And what else? Let's say gender. So here I can use numbers as serial number. Name of member, so I'm gonna type here my name, right? Let's say my name is Chavi Kalra, and my date of birth is, let's say, 1st January, and my gender is female. And then I'm gonna use another name, let's say Arun, and I'm gonna say that the DOB is, let's say, 1st Feb, and the gender is male, right? And then I'm gonna use a third name, let's say Simran, and I'm gonna type 1st March, and again. Now guys, this is a structured data. It has a proper structure. I know that this first row is representing data of one of my family members or myself, whose name is Chavi, and she was born on 1st Jan and she is a female. A second member of my family whose name is Arun, uh, who was born on 1st of February and he is a male. Now, guys, okay, why does it matter that it has a structure or it doesn't have a structure? Now, that might be more understood when it will come to a point where I need to use this data in some form or the other, right? Right now, in this table, it might not seem that, okay, what is the use of this? Why do I create a table for this? But right now, you're looking only at one family. When it will come to thousands of families and thousands of members of those thousands of families, or maybe it, of course, it will come to millions, then count will be, of course, infinite. When it comes to that point, then it will be very difficult for you to find out a particular information about a particular user. Think of a table of employees of an organization, or think about a shopping mart. In a shopping mart, there are thousands of items placed on those shelves. Every item is uh, is there. It is in the catalog, is placed in the catalog, and their information is written there. Every item has a barcode, right? Every item is indexed in a table, and we need to make sure that each and every item is tracked, of course, right? It's a shopping mart. Losing even one item could lead to loss, so that's not the point. Although the point is that structured data helps you keep uh, track of those items. If I need to find a particular item, I can go to the table, I can search for it. Of course, I'll have to use some sort of search mechanism here, but I can search that, okay, I need to find this particular member of this particular family, and I can fetch the results. Or you can apply the same mechanism to a table of a shopping mart, or employees of the organization, or let's say a table with the information about all the patients in a hospital, in anything, right? You can think of hundreds of other such scenarios where structured data can be used. All right, so I hope this is clear, right? In structured data, we have rows and we have columns, and now guys, now understand the difference between structured and the unstructured data. Do you think there are rows or columns in this video or word or a ppt file? No, right? I mean, of course, I'm not gonna go into the back end, right? Or like how this data is stored on a magnetic disk or any kind of storage system. Of course, there is a format there that how the data is stored. But right now, we are discussing in terms of this rows and columns. All right. Now, then comes semi-structured data. Now guys, semi-structured data, it is not exactly rows and columns, right? But the point is that the same data which I'm storing under structured kind of category, I can represent the same data in a semi-structured way also. Now, when I talk about semi-structured data, so you guys might have heard about JSON files, right? Or you might have heard about let's say .xml files. Now these are different type of formats in which the data can be stored. Okay, I am gonna give you I'll show you an example of a JSON and a XML file, right? So let's say we have this JSON file. Now guys, this is one of the JSON template. uh, it's a JSON template for creating a virtual machine in Azure. Now I want you to observe uh, the type of structure it has. So a JSON file, so we don't have rows and columns here in JSON file, right? We just have these curly braces, and then in curly braces we are using double quotes to define our data, right? We are using for example, let's talk about parameters. So I have defined multiple parameters here. See, guys, observe this. In a table, when I wanted to define information about a member of my family, I'm using columns for that, multiple columns, and then I have data about uh, like this particular entity. When it comes to a virtual machine and I'm defining that information about that virtual machine. So where is it gonna get stored? What will be the name of the network interface which will be attached to the virtual machine? What will be the name of the network security group? What are the rules? What is the name of the subnet, or the name of the virtual machine, or the name of the computer, or the size, or the username of the administrator, and so on. So what are these? These are just some properties which I am defining to create a virtual machine, right? Ultimately they are properties. Here also, what are these? These are properties of a particular member of my family, right? So ultimately we are defining data in a different format. That's all. This is a JSON file, right? We use curly, see, this is the format of a JSON file, right? You define the properties and then you specify the value of those properties. Or you can define the type of data that particular property would contain, whether it will be a string or whether it will be an array or it will be an integer, right? So we define that. Okay. Apart from JSON, what was the another example? We had an XML file. So I want to assume in our early days, like schools or universities, we all had learnt about HTML tags. Although this is not HTML, this is XML, but guys, XML also uses tags. Okay, again, when you go to let's say an electronics store, definitely that electronics store would have a database where all the appliances will be listed out. Now it is up to you that okay, not up to you, basically it is how easily, how efficiently you can process the data, how easily you can make sure that the data is current and valid, it is not old, right guys? XML files have have a separate agenda as to why they are used, right? They have a different purpose. But my point here is that you can define the data in an XML file also. Like here, if you observe, I am defining that, okay, in this electronics, if the spelling is wrong, electronics section, uh, I have an appliance category of air conditioner, right? The manufacturer, the model, the price of the appliance, and then I'm defining multiple appliances, right? So this is an XML file. So guys, this is your semi-structured data. It may not have a proper structure, but proper structure like a row and data, but it definitely has a structure and a way of defining the data uh, in a file. All right. Now, that is your categories of the data.